Hey folks, Azure Cosmos DB TV. I'm Mark Brown, and this week I've got with us Richa Gaur. How are you, Richa?
I'm good, Mark. How are you doing?
I'm doing great. I know it's late over there, so thanks for joining at a very late hour. Let's see, it's 8 a.m. here in Redmond, so it would be 8:30 p.m. where you are. Did I get that
Yes.
time zone change right? Okay. I sometimes screw it up. I go the wrong way. But thanks for joining. And we're going to talk about throughput groups this week. So brand new feature, or sorry, did I get that with throughput buckets? Is the feature. So you're going to show us or talk about, I guess, why would you use these things? What customers were telling us about this, and then kind of go through kind of how they work. And I guess we'll see a little demo, and then I guess really watch them in action here as well too. So yeah, why don't you lead us off? Tell us all about throughput buckets.
Thanks, Mark. Hey, everyone. I am Richa Gaur. I'm a product manager in Azure Cosmos DB team. And today we are going to see how we can improve the performance of multi-workloads running on the same container with throughput buckets. So let's get started. Mark has already covered the agenda, so I'm going to skip it. So let's start with the problem first. So often than not, Cosmos DB users end up running different workloads on the same container, and most of the times these workloads have distinct performance characteristics. So what happens is sometimes one of these workload will utilize excessive RUs, or there is unpredictable traffic for one of these workloads, and what ends up happening is it ends up impacting other workloads, and sometimes real-time workload, customer facing one, which leads to performance degradation and worst case scenarios, business loss as well. The common patterns that we have observed among our customers is when, in cases of ISV, if they're running multi-tenant workload on the same container where they have different tenants with, varying request volume and performance characteristics, and they end up impacting one another's performance due to these unpredictable RU usage. A lot of times customers run bulk execution jobs along with the customer facing workload, which ends up since these are bulk execution job, they tend to be very high throughput jobs, and they end up impacting the front end workloads where with the end consumer is interacting with for the application. Sometimes data ingestion, migration processes, although these are rare, definitely impact real-time applications and cause a lot of throttling in the container. In certain scenarios, we have seen that execution of stored procedure as well as change feed processing can lead to adverse impact of your on your real-time applications, and container ends up getting throttled quite a lot and impacting the front-end applications. To address all of these varying challenges in varying category of throttling, we have introduced a new feature called Throughput Buckets. So Throughput Bucket is a concept which allows users to set a maximum cap of throughput limits to control the resource consumption of a specific workload. Consider bucket as a group where you can categorize one workload or multiple workload to that particular group. These group or buckets are numbered, and these are assigned RU caps as percentages of total provision throughput. And to associate a particular request or a specific workload to these buckets, what you need to do is you need to just tag these requests with the throughput bucket in using SDK properties. And once the requests are tagged, Cosmos DB enforces that the throughput limits of the specific buckets are honored, and and the usage is kept within the maximum cap that is configured for that particular bucket to ensure the control and governance of throughput usage for a bucket. In any case, if the request is sent without any throughput bucket, it can continue to consume up to 100% of containers throughput. So it can facilitate use cases where you need to use all of the available throughput, so you for your priority workloads. So throughput bucket basically enables a different kind of different use cases. So you can use throughput buckets to maintain API responsiveness even in case of high load and scheduled background operations to ensure smooth user experience. The customers are not impacted in those scenarios. You can also use throughput buckets to prevent noisy neighbor issues in case of multi-tenant workload. So that one, you can isolate and govern the usage of throughput of one tenant from another tenant, and each tenant can continue to perform according to their characteristics. You can also utilize throughput buckets to support differentiated service tiers in multi-tenant applications. So you can tailor the performance of your application for different tiers predictably without restructuring your data model or creating a separate container for different tiers. So all of these different use cases and beyond this can be unlocked with throughput buckets. Let's move on to see how we can configure and manage throughput buckets. It is with Azure portal, it is pretty simple. All you need to do is go to Data Explorer and go to the Scale and Settings tab in the container in your Cosmos DB container. There is a throughput buckets tab, which you are not able to see in the screenshot, but it's there. So here are these buckets. You can go ahead and enable any of these buckets and set a maximum percentage of throughput to be consumed by this bucket. So you can set anywhere between 1 to 100% for one particular bucket. Customers can only create up to 5 buckets within a container. So now that we have seen how throughput buckets can be configured and what they do, let's see how they work in action with a demo. So for today's demo, we are taking retail marketplace platform called Contoso Marketplace. It is a multi-tenant retail solution offering end-to-end retail platform for businesses. It offers 2 differentiated service tiers. One is the basic SKU, which offers the standard offering, and another one is the premium SKU, which has enhanced enterprise features along with better throughput and availability. So let's go ahead and see how Contoso Marketplace utilizes throughput buckets to improve the performance of premium tenants in cases of contention. Let me switch to.
Can I ask you a question while you're teeing that up?
Sure.
So could I use throughput buckets with what is the name of that feature? Is it burst capacity? That's it.
Yeah. Today, this is not possible, but we are working to improve the composition with burst capacity. So you'll probably see this working along with burst capacity as well.
Okay. I got another question. So our Java SDK has these throughput control groups, right? And you can have that either as a single instance within the SDK instance, but you can also create these global ones as well. Does this feature kind of competes with that Java SDK kind of feature in a way, doesn't it?
Yeah, compete is probably a strong word.
No,
I would
not
say.
Compete. It's synonymous, I guess, in some, right?
Yeah, it's exactly.
Go ahead.
Yeah, Yeah, you got that right, Mark. It's exactly the same feature. The only difference is that the Java SDK throughput control group feature is a client-side feature, and we have and it's only available for Java SDK. While
Yeah.
throughput bucket is the server-side implementation of the same capability. So you have the control, and governance happening directly within our Cosmos DB backend service, and so you have like faster response to the usage and throttling behavior in this case. The only thing is the only difference is client side and server side. There is no other difference per se in the behavior of these two features. And since this is a service side feature, you have it available for all the other SDKs as well as Java SDK for that matter.
Got it.
So
So .NET, Python, JavaScript developers that were maybe jealous of what our SDK could do
yes,
can now enjoy that similar functionality in their own
yes,
use. So, and also
yeah.
Rust and Go folks, I guess, as well, right? So everybody gets happy with this.
Yeah.
Okay.
There's just to continue on that, I just wanted to quickly add one more point over there. With the service side feature, you get a bit more simplicity as compared to the client side feature, where you don't have to create a metadata container for global throughput control in Java SDK.
Yep.
So you get a little bit more simpler configuration compared to the client side offering.
Yeah. Okay. Makes sense. Okay.
Yeah. Okay, so let's go ahead and run the demo. So, today we are simulating two scenarios. So let's first run the first scenario, which is the multi-tenant product search workload. So we have two categories of offering the basic SKU and the premium SKU. And we have tenants which have subscribed to basic SKU as well as premium SKU. So all of what we are simulating is the product searches happening by the end user, operating by the end user of these retail platform, and all of these queries from different tenants are coming simultaneously and running concurrently on the container. So let's first see how this works when we don't use throughput buckets. We already have the container set up, so I'm going to skip this step as well. So what we are doing is we are running product search queries for both basic tenant and premium tenants. While this is running, let me quickly show you how the container looks like. So this is the Contoso Marketplace database, and we have the product catalog container. And this is what a document which represents a product in an e-commerce website looks like. So here for this container, we have like different product related metadata, and for this container we have created hierarchical partition keys, and this is a multi-tenant workload. So for the first level of key is the tenant ID, and the second level of key is product ID itself. And we have these different different types of documents for each of these tenants. And right now we are running the product search operation for both the tenants. Let's just wait for a few seconds till this completes. Okay, this is done. Okay, so we can see that yeah, it has run like quite a lot of operations within last 1 minute. And we see throttling of around 26% for both basic and premium tenants. So we are seeing like similar throttling for both the tenants. This is expected because we have just let me just show you the scale as well. So we have provisioned a 400 RU throughput container, and since we are running significant number of queries at the same time, the throttling is happening. So both the basic tenant queries as well as the premium tenant queries are getting throttled. So now let's see how this works when we enable throughput buckets. So we'll run the scenario 1 again, and this time we will use throughput bucket.
Got it. This works with autoscale too, right?
Yeah, this works with that. This is just for demo purpose with the small
manual. That's cool.
Yeah. Okay, so what I've done here is I have used throughput bucket. Let me show you how that works. So here we have a throughput bucket tab as well. So what for this container, what I've done is I've created two buckets, bucket one and bucket two. Bucket one has 10% maximum RU utilization, configured basically, and bucket two has 40%. So for scenario one, what I'm doing is I'm using throughput bucket two, basic tenant throughput bucket. Basically, what this facilitates is for the basic tenant queries, it can only consume up to 40% of containers throughput, and it cannot go beyond that. And we are when this is when we have enabled when we enable throughput bucket, we are passing this throughput bucket for basic tenant queries. That's how this is being implemented. It's done. So as you can see, the basic throttling has increased significantly, while premium tenants performance has improved drastically. So from 27%, it has come down to 9.44%. And this is because of the fact that now, since basic tenants RU utilization has been capped to 40%, it is not able to go ahead and consume all the available RUs. Hence, there is more availability of throughput for premium tenant, which we want to prioritize for our applications, since they are paying more and we are offering better throughput and availability. So that's why they're able to see better performance in cases of contention as well. So this is, this is how you can probably utilize, throughput buckets to prioritize one workload versus other by setting a cap for the low priority workload and letting the high priority workload utilize all the available throughput for the container.
Back in the portal, I noticed that the first bucket, I guess it's late there. They turned the lights off. There you go.
Yeah. Sorry.
Back in the portal, I noticed the first bucket was tagged for Query Data Explorer in the portal. So that's just kind of a default. It always uses bucket one. And there, you could use it, I guess. You could assign it, I guess, in your application, but it's Data Explorer always going to use one. Is that the way that works?
Yeah, that's correct. So whatever query you run through the portal will always utilize bucket one if it is enabled. So if I just disable it, it won't utilize. But if in this case it is.
Oh, I see. So you just turn that bucket off. But you could also just use it in your app as well, right?
Yes. Okay. So so what in the next scenario that I'll demonstrate, will use bucket one. So let's go ahead and see that.
Got it. Okay.
So the second scenario that we are running is the concurrent inventory update with product searches. So what we are simulating here is in a lot of retail platforms, inventory update is a regular operation that happens during off business hours. So this is a bulk execution job which will insert new products or update existing products, their prices or anything for that matter. And since this is an off business hour activity, it is generally done during nights and things, basically during off peak hours. But still there are certain product searches happening because we have a real-time application, it is always on. So we have this product searches, although significantly lesser in quantity, running along with the concurrent product updates. So let's go ahead and see how this works. Okay. So as you can see, we are seeing significant throttling for both basic and premium SKU tenant, and inventory job has also seen some throttling as well in this case. But this is not a good experience for our customers, because if I'm a e-commerce platform user and I'm doing a product search, and if it is returning error, I might abandon my purchase altogether, and that can lead to business loss. So even though there is a background job that is running, which is essential, we don't want our customers to suffer because of that. So what we'll do is we'll run the same scenario again now with a throughput bucket. and see how that changes the performance for our product searches. So in this case, we will be using bucket 1 to cap the throughput usage for inventory update. Let's see that in code as well. So we have this inventory job throughput bucket, which is 1, and we are passing that bucket in our execute bulk inventory update method. I'll go through the code in a while, but this is what we are doing here. We are passing the throughput bucket, and we'll see. So now you can see the throttling has significantly reduced from 74, almost 74, 75% to 39 and 29% in this case, which is a significant reduction. And this is due to the fact that we have capped the inventory job throughput utilization to just 10%. And you can see the impact of that on the inventory job. The throttling has significantly gone up to 94% because it has just 10% RU available, which in this case is 40 RUs, which is significantly less. But to demonstrate the concept, we have prioritized the product searches with the customer-facing workload against the background operations. So this background operation, as you can see, has significant throttling, but this is an operation which can, take longer time to finish because it's running in off-peak hours, and we don't have immediate latency requirements on this. So it can, the latency can increase and it can take a longer time to finish, which is what happened in this case as well. It took a longer time to finish, but this is a trade-off that we have to consider. Since we need to prioritize our front-end workload, we need to find a balance between our latency and throttling requirements for different workloads and accordingly configure the containers throughput as well as the max limit for each bucket that we are going to utilize in the code.
I think with these kinds of workloads, this is a much simpler approach than other patterns you might have to take, like maybe doing some kind of queue-based load leveling or something where you're essentially kind of building built-in kind of throttles on ingestion rates for these types of operations that could run in the background, and frankly could run and have retry policies with back off and all kinds of stuff where it doesn't matter if the thing gets kind of queued up or has to retry 100 times or whatever, because it's a background process. Who cares? You want to prioritize that user experience where you need snappy performance all the time. So I love that this just drastically simplifies. Like, you could spend a lot of time engineering a way to do a queue-based load level in there versus having just this as a way of much easier implementation. Can you show kind of, so this happens, you apply this throughput bucket at the container instance level, or can you show me in your code kind of how, where you apply that?
Yeah, sure. So let's see the first scenario first. So what we are doing is we are simulating product searches and we are passing throughput bucket if it is enabled for basic tenants. So what we are doing here is we are just taking all the tenants and we are simulating product searches. This is just creating queries, and for basic tenant queries, we are passing the throughput buckets here, while in the case of premium combos, it is none. So what we are doing is we are running these query tasks simultaneously, and we are waiting for these tasks to complete. So these tasks are running concurrently, which is what actually happens in the real product scenarios. So if I go to the execute query method, I'm just simulating a product type search. So let's say I'm looking for, let's say iPhone, for instance. I'll just go ahead and type phone, and this is what this query will simulate. And we are passing, what we are doing is we are passing throughput bucket in the request itself. So this is the query items API. And if the throughput bucket was passed in the method, it will be directly passed to the query. So what happens is now this request is tagged with the particular throughput bucket, which is 2 in this case. And once that request reaches to Cosmos DB, the Cosmos DB will ensure that the bucket level limits are adhered and the max percentage is honored. So if
Got it.
the active usage is exceeded, it will throttle this particular query.
Got it. So you get an optional property on the query items function on the container object. What about on doing inserts and updates? So doing writes.
So yeah, this is a request property, request options. So you can pass throughput bucket for any type of request. There is no such restriction. So you can pass it for insert, updates, delete, query, or any other API for that matter.
Oh, can you show me on your updates how you're applying the throughput bucket then?
Yeah, so that's a different scenario. So for the second scenario, what we are doing is we are running a bulk inventory update job with the product searches. So again, these two are happening in parallel. And in this case, we are passing throughput bucket in this for the bulk inventory update job. So in this case, this is slightly different. What we are doing is we are creating a Cosmos client with throughput bucket itself. So let me walk you through this.
So it's on the it's on the connection object. So it's a connection option.
Yeah, so this is a Cosmos client option, and we are passing throughput bucket. So what happens is when this client is used to do the insert operation, all the insert request will be tagged with the throughput bucket one in this case. So if I go here and if I just show you the code, there is no throughput bucket option explicitly at the request level. But since the container was created with the throughput bucket option, all the requests will automatically be tagged with throughput bucket one. So there is both the option available based on the different use cases that you want to,
Got it. No, that's quite flexible, right? Because those types of background operations may do reads as well. So if you define it the query, fair enough. That's great for doing queries where you want to limit those. But on any kind of other operation, whether it's these background tasks where you're doing inserts, updates, deletes, but also include reads on there, you define it at the connection level. So basically everything within that kind of routine or that process is gated based upon the throughput bucket value that you've passed into the connection options there. So that's cool. Okay.
Yeah, although this is not very apparent in Python, but in other SDKs, we have this bulk API, bulk mode. So basically, it is very handy for bulk mode where you just enable throughput bucket at basically the client level where your bulk mode is also enabled. So any bulk requests are getting tagged with the throughput bucket, so which tend to utilize the all available throughput. That's how the bulk works.
And absolutely, you would also use that with bulk mode so that you can basically batch up the dispatch for any requests that are happening as well, and kind of reduce kind of network load and request load as well on the service side. So that's absolutely. You would want to use those hand in hand, it seems. So, yeah, so very cool. I like the implementation. It makes sense. The design is nice, and it, like I said, it's flexible in how you can apply that for the different scenarios. So very cool.
Yeah, thanks. I would also like to just demonstrate how you can monitor the performance with different throughput buckets through metrics. So we have total request preview metric and total request unit metric. So let me just quickly show you how you can. I'm just looking for one option. Let me know if this is still visible. Is it?
Yep, I can see it.
Okay, so yeah. So I'll just add the throughput bucket and status code as dimension to quickly show how this worked. So as you can see, if you want to just see how many, how the request performed with throughput bucket, you can see that you can just go ahead and split by throughput bucket and status code as well as operation type or any other dimension for that matter, and you will see that here empty represents that no throughput bucket is applied, and 2 is the throughput bucket that we used for our basic tenant, basic SKU tenants, and 1 is the throughput bucket that we used to that we use to basically control the inventory job utilization. So you can just go ahead and split and see how your throttling and the success rate varied with throughput buckets. So just to show you, earlier our 4 to 9s were high when we didn't have any throughput bucket applied, and it consequently lowered when we applied the throughput bucket. And you can consequently see that the 200s have increased, and 4 to 9 for the basic tenant have increased, and 4 to 9 for the premium tenant has reduced. So that's the kind of impact that you can see and measured through metrics as well directly.
Yeah, very cool. Could you use this? So I had Deborah on last week talking about kind of the fleets management stuff. So, and that designed specifically for kind of the multi-tenant ISV scenario that you kind of listed at the beginning there. Could you use these together and use fleets and pooling there for handling multi-tenant ISV, and then within each tenant use throughput buckets to handle these types of varied operations that you've got going on?
Yeah, that's an interesting proposition. We are actually working with throughput pooling to figure out a composition that works at fleet space level, since fleet works at at a very high level where you have like multiple subscriptions account and like different resources and their hierarchies under fleet space. And if you look at throughput bucket, it is configured at a lower level at container level. So although you can you can continue to use these in combination, but there is no way to directly apply throughput bucket to pool RUs, which is configured at fleet.
No, I wasn't suggesting that, but you could compose these together in such a way that you could use the fleet and the throughput pooling in that sense to handle kind of tenant issues, which is one of the ones you had mentioned at the start of the show. But then also within each tenant handle these scenarios where you've got you need snappy reads from customers, but also you've got these background processes happening as well in there. So it just suggests you could compose these together and use them together in there as well. So, and then of course there's the burst capacity as well. I don't know how you'd make that square that circle, but more fun, I guess, for us to figure out if we make that work in there. So, all right. So some FAQs, I guess you want to share. I don't know. Did I hit any of your questions there in there? Oh,
no, I think, yeah, you pretty much covered a lot of open questions we have and the roadmap from preview to GA. So currently we are in public preview, and we are waiting for customers' feedback on the utilization and how they are solving different scenarios with throughput buckets. So that we'd love to see that feedback and iterate upon wherever if there are any gaps. And we have these compositions lined up with throughput pools, bus capacity, etc. So we'll see these improvements on path to GA as well. So yeah, I think we are pretty much covered that way.
Got it. Okay. Yeah. So okay, I'm looking at number 6 is interesting. So you could set a throughput bucket to 0 in there. Let's just say I've got some client and they're going hog wild and chewing up all my throughput in there, or I say I want to kill something. Could I use a throughput bucket and just set it to 0 and effectively kill whatever's going on there?
Yeah, that's an interesting thought, but today you can't do that. We have minimum 1% configuration for throughput bucket. So what that means is a lot of users actually confuse these limits with reservation. So that's why I've mentioned when I say 1%, it's a maximum 1% that you can utilize with that bucket. It's not the minimum cap. So it's not like 1% is reserved for this bucket. There is no concept of reservation with throughput buckets at all. So it's purely first come first serve basis, the way Cosmos DB works today. So whichever request gets first, that utilizes throughput, and that throughput gets consumed. The limit just ensured that the maximum cap doesn't go beyond the configured percentage.
Yeah. And then I see in there, I guess, to my kind of ridiculous scenario, you can only make a change once every 10 minutes. Does that mean if I make a change, it takes 10 minutes to kind of replicate through our front end and compute layers?
No, not exactly. So this is just a rate limiting mechanism that we have on our throughput APIs, since there could be millions of partitions in the background. So frequent updates are not advisable. But once you apply and the operation has succeeded, it means that it has applied to all the partitions. So
Got
it doesn't.
And that's a control plane operation defining the buckets, right?
Yes, that's correct.
Okay. And does that hang off the database account resource, or is it per container resource? Where are buckets sit within that resource hierarchy within a Cosmos account?
Yeah, it is at bucket level. Oh, sorry, container level. So you
container level.
Yeah.
Okay.
So you
Yeah, that makes sense.
Yeah.
That makes sense. All right. Can I use them if I have shared database throughput?
Not at the moment.
Okay.
You can.
That's okay if you don't do that. People need to be careful shared throughput anyway. We don't need to lead more people down that path. But okay, cool. Anything else? I think we saw everything, didn't we?
Yeah. I think we have covered almost everything.
Let me. So I know you got this GitHub repo, and tell us what we've got here. I put this link up here for folks to get started.
Sure.
I mean, you can just talk about it. It's fine. But you got a GitHub repo. What can they find on that repository here for Throughput Buckets?
Yeah, so we have quick starts in each language. We have currently in .NET, JavaScript and Python is coming pretty soon. And we have you have this the demo that I just showed. It's written in Python, so you have a Python code sample as well, the end-to-end demo, and the quick start available. So you can just go ahead and try out that quick start.
Okay, so people can go and clone or fork that. You got Python sample in there now, more coming, more explanation, resources, and other stuff like that. And then, of course, also docs. So people want to go and read our docs on this as well. They can go and check out that docs link, aka/ms/cosmosdb-bucketing. So, all right. Well, that was really cool, Richa. Here, I'll put this other one back up. People want to see that. Thank you very much for coming on and showing us throughput bucketing. This is a very cool feature. I think people are really, I know this hits a very common request from customers that are building complicated workloads and customer-facing workloads as well using Cosmos DB. So this is a great job. Very cool feature. I like it very much. So, and I think our users will as well. So thanks for coming on, Richa. It's good seeing you, and come on back anytime.
Yeah, thanks, Mark, for inviting me, and it's been a pleasure. Thank you so much.
All right, and thank you, everyone, for joining us this week. We'll see you again next time. Take care.